Hello everyone, welcome to part 2 of our proportion similar triangles lesson here. Alright, it says triangle ABC and triangle DEF are similar. Find the missing side length. Okay, so they were nice. They actually drew them in the same orientation to each other. But if they weren't in the same orientation to each other, you could use the fact that the order that they were written up in the problem here is telling us the order of how they are similar. So since A is first and D is first, that's kind of the corners that match up. And then since B is second and E is second, those match up. And lastly, C and F. So we can see that they're in the same orientation. If we had spun the second triangle around, you know, it would still, we'd still have to match up those sides. We might have to do more work in a different situation. Okay, so because of this, we can make a proportion to solve for our missing side here, where they put a question mark. I might use an X for that. All right, so we have lots of different options. I see that we know this side is 12 and this side is 4. So we can put 12 over 4 as part of our proportion. Now, we want to definitely use the side where the missing piece is, so we have to use the matching side from the other triangle, so where the 21 is. So notice in the first ratio, 12 over 4, I used kind of the left triangle, the triangle ABC, on top. So I still have to use triangle ABC on top here. So I'm going to put 21 on top, and then I'm going to put the X on the bottom there. Now, because we did a lot in the first part of this video with cross product equations, why don't we do this one by scale factors actually, because this is easier. So to go from 12 to 4, we would multiply by 1/3. So we can apply that same process to the 21 here. And if we do 21 times 1/3, we get X equals 7. And so that is the missing side length that we need for side EF. Wonderful. Okay. Here we have pentagons ABCDE and JKLMN are similar, and we can definitely see that they're in the same orientation there. There's no confusing that. It says find the length of JK. It's not a joke. Man, they just walked right into that one, didn't they? All right, so JK is right there. So we're going to have to use that side, which means we're also going to have to use the side here. So then really we're up to finding any other two sides that we seem would be like a nice pair. And we have so many choices. We could pick these two sides, CB with LK. We could pick CD with LM. We could pick DE with MN or EA with NJ, and it doesn't really matter. Okay, what it does matter is how we set them up. So if I do the greens first, 4 over 2, those are going to be equal to the blues in that same order where we start with pentagon ABCDE on top. So that is going to be the 5 on the bottom there and the X. Okay, so once again I see a nice scale factor. I can go from the top to the bottom with a scale factor of 1/2. When we do 5 times 1/2, we don't get a great number, so you could represent this certainly as X equals 2.5, or 5 times 1/2 is 5 halves. So either one of those is certainly correct. Terrific. All right, next we have a more tricky example of similar triangles. They didn't even necessarily in the directions say that they are similar. So there are a variety of rules that tell us when triangles are similar. And so one way that we can know that triangles are similar is if all 3 angles in the one triangle are equal to all 3 angles in the other triangle. Well, they've already told us one. This angle's a right angle, that angle's a right angle. Now, in geometry, when 2 lines intersect, like these 2 lines do, the angles that are opposite each other are equal. And the name for these angles are vertical angles. They kind of look like they make a V. Maybe that's how you can remember their vertical angles. So vertical angles are equal. So if those 2 angles are equal and the 90-degree angles are equal, the other angles have to be equal because every triangle has the same sum of all its angles, which is 180. Now notice I put 1 arc in those angles that are kind of touching there. I'm going to put 2 arcs. That's kind of like a matching system. Say that these 2 match with each other. Okay, so that makes them similar. Now the tricky thing here is they're not in the same orientation here. One's kind of got a 180 spin around from the other one. So let's play the matching of sides games. So hopefully it's a little bit easy to see that the 3 up top matches with the X on the bottom. Terrific. The 6 and the 7 are also matching. They didn't give us information for this side, but these two sides would be matching. And, if you're in doubt, some of the things you can use would be helpful. Some of the helpful information you could, think about here is, okay, this 7 is between the angle with the 1 arc and the angle with the 2 arcs. What other number is on a side between those two? Well, here's our 1 arc and here's our 2 arc, so the 6 is in between those as well. So you could do things like that to try to make sure you're matching them correctly. Okay, long story short, we need to set up a proportion. We found out which sides match. I can put the 6 over the 7. So that was kind of my top triangle is on top, bottom triangle is on bottom. Great system there. All right, and so then we're going to do the top triangle's side 3, and this one's side is X that matches with it. All right, so in some of the past examples, we did vertical scale factors, but this time we can do a horizontal scale factor. So to go from 6 to 3, we'd multiply by a half. So we want to do the same thing here. So 7 times a half is either 7 halves, or if you like the decimal equivalent, 3.5. Wonderful. Okay, whoa, word problem, but it comes with a picture. That makes it better, doesn't it? All right, a woman wants to measure the height of a nearby tower. She places a 10-foot pole in the shadow of the tower so that the shadow of the pole is exactly covered by the shadow of the tower. The total length of the tower's shadow is 196 feet, and the pole casts a shadow of 5.25 feet long. How tall is the tower? Round your answer to the nearest foot. Hey, this sounds maybe almost insane, but this is actually useful, and people can really do this, especially before we had sophisticated technology that could measure things. People could literally figure out how tall is that tree. If I chop it over, is it going to land on my house? They can do this with shadows. I had an assignment in college where I actually was sent out to do this. It was actually for a teaching class. All right, so here's the pole right here. It's standing up here, and its shadow ends exactly where the whole tower's shadow ends. So we have two triangles. They're on top of each other. So I'm going to draw them out unoverlapped. So there's our little triangle with the pole, and here's our big triangle with the tower. So the one thing you'll note is that they both have this same angle here, and of course they both have a right angle here. So it didn't mention that they were similar triangles, but they are similar triangles. This third angle must be equal for both of them, and that's why we can do the work we're about to do. Okay, so let's label some information. The pole is 10 feet, great, and it casts a shadow that ends in the same spot. Okay, down here's where the shadow is, the pole's shadow is 5.25, terrific. The total length of the tower's shadow, so that's along the ground here, is 196. And you're like, well, how do we measure that? Well, at least it's on the ground. We can measure things on the ground. You can pace it off, whatever you have to do to get a measurement on the ground. Measuring things up really high that you can't reach, that's a lot harder. Okay, so we're going to try to find the height of this tower. Hey, look, similar triangles, we're ready to make a proportion. So many different ways we could do this. Let's stick with little triangle. Its height is 10 over its shadow is 5.25, and that's going to be equal to the tower's height, x, over 196. All right, definitely an instance where we wanted to do our cross products. So we get 5.25x is equal to 10 times 196 is 1,960. Okay, so great. We're now ready to go ahead and divide both sides by 5.25. 1960 divided by 5.25 is 373.3 repeating, and it says to go to the nearest foot. So we just have to go 373, and since it's 0.33, it'll round down, so it's 373 foot tower. So 373 foot tower. Terrific. Wow, that was awesome. You can go out and measure the height of your house now if you're so curious. All right, last one here, scale drawing. So we have a wonderful, exciting table. I'm sure you want to feature that in your living room. Just Really stylish. In a scale model of the table, a 1 centimeter represents 5 inches. Okay, terrific. It says answer the following. In the scale model, the length of the table is 8 centimeters. Okay, in the scale. What is the length of the real table? Okay, so this scale that they gave us is part of our proportion. So I'll put the 1, and I'll keep the centimeters there so we don't get lost in the 5 inches here. We won't necessarily need to use them when we're multiplying here. Okay, but now we have, in the model, it's 8 centimeters. Okay, so that's going to stay up top because that's our centimeters on top. And so we're looking for X amount of inches on the bottom. Okay, pretty nice and easy proportion for us. To go from the numerator to the denominator, we multiply by 5, so we're going to do the same thing here. And so 5 times 8 is 40 inches. So the table is 40 inches in length, 40-inch length of table. Table. All right, next, it says the height of the real table is 25 inches. What is the height of the table in the scale model? Okay, so they gave us basically a different piece, but we're still sticking with this 1 centimeter over 5 inches from our scale. But since they gave us the real table, that piece of information is going to go down on the bottom, 25 inches, and we're looking for X centimeters up top. Okay, well, notice I see that we can go use a horizontal scale factor of 5, and so we know that 1 times 5 is going to give us 5 centimeters of height in the scale model. Terrific. All right, so this was part B here. This was part A there. Terrific. I hope going through these helped you complete your assignment and know a little bit more about proportions, scale factors, and their applications in geometry.